the scalar product of two vectors. So this lesson we're talking about how to find the scalar product of two vectors and how to find the angle between two vectors. So the scalar product of two vectors, which results in a scalar. So remember, scalar just means number. That's all scalar means. Anytime you see scalar, it's just a number. So it results in a number answer. So understand when you do a scalar product, you should just get an answer, a number. And the notation is this right here, v dot w. There's also a vector product, which we don't talk about in SL, so let's get past that. So here's a scalar product. It is in your formula sheet. Scalar product of two vectors, also known as a dot product, is where you get these vectors here, and you just multiply across. So v1 times w1, v2 times w2, v3 times w3, and you add them up. And that's it. That's dot product or scalar product. So for example, if we had two vectors like this, and I said what is a dot product? All we do would multiply the corresponding parts. So 2 times 4 plus 3 times 1. Now I would get 8 plus 3, which is 11. So that's how you do scalar product. Again, that formula is in your formula sheet. So we use a scalar product mostly to find the angle between two there and to deal with angles in general of vectors. So let's next talk about how to find the angle between two vectors. So here's the key thing about finding angle between two vectors. Let's say I give you this vector v, v1, v2, v3, and this vector w, w1, w2, w3. By the way, this works also for the 2D vectors where there's not a third term. It works for both cases. The key thing about finding the angle between vectors is how you draw the angle. That's the most important thing. So if they give you a vector v here and a vector w there, and you're trying to find the angle between vectors, there's a very particular way you gotta draw it. And that is you draw it basically tail to tail. So like this. Like this would be vector v, this would be vector w. If you have that, this is the angle between the two vectors. So it's different than adding vectors or subtracting vectors. When you want to find the angle between two vectors, you draw them like connected at their bottoms, at their bases, as you can see right here. And then if you want to find that angle right there, we have a simple formula for it, which again is on the formula sheet, and that is this right here. Cosine of the angle right there equals the dot product of the two angles, the two vectors, sorry, over absolute value of v, absolute value of w. Remember what that means? Magnitude. So the formula is just, if you want to find cosine of this angle, it's just made a dot product of those two vectors over the magnitude of those two vectors multiplied together. And then like since most time you're finding the angle, you eventually have to do like cosine inverse. And this is scalar product or dot product. So that's the formula. So you just gotta remember that when you draw your vectors, draw them like when they're connected to tails. That's how you find the angle, and then you just use the formula. So with that in mind, let's do a couple examples. So here we have P and Q, and the first question is find the dot product of P and Q, or the scalar product of P and Q. So to do that, we just multiply the corresponding parts. So I'm going to do 2 times negative 1, plus 3 times 0, plus negative 1 times 2. Add them up, you get negative 4. So the dot product of P and Q equals negative 4. Next, let's find the angle between the two vectors. Now, in this case, I don't have to decide the two vectors. I don't need to draw it. Like angle P, angle Q. It'll be like that. That's the angle I'm finding. Since I have the two vectors, I don't need to do anything special. Let's use the formula. So for B, the formula is cosine theta equals the dot product of P and Q over the magnitude of P and Q multiplied. Now we already found the dot product over here, negative 4. Now you just got to find the magnitude of each one separately. So let's do on the side here, magnitude of P. Remember the formula for magnitude? It's in your formula sheet. It's just essentially quadratic formula with Pythagorean theorem. I always say quadratic formula. It's Pythagorean theorem. In this case with 3 terms. So that'll get me 4 plus 9 plus 1, or rad 14. Same thing for Q. This one should be a little easier. Negative 1 squared plus 0 squared plus 2. Remember, every time you square a negative, it's positive. A lot of people give me negative 1 for that. I don't know why. It's positive 1 squared. Plus 4, so rad 5. So if I plug this all into here, I have this right now. Cosine theta equals negative 4 over rad 14, rad 5. If I want, I can multiply this, make it 5 times. I can combine it 5 times 14, which would be 70. But this is rad 17, which would be the same thing. Now again, I want to find the angle, so I just have cosine. So in this case, I'm gonna bring out a calculator so you can inverse cosine this. It's a percent. If you want to rate into degrees, it's up to you. I think by default my thing's in radians, so I'll just leave it there for now. We'll change it in a second. So if I want to solve this, I gotta do cosine inverse on both sides. So that's right here in second, cosine. Now the easiest way to put a fraction is to use the alpha button to your advantage. So alpha y equals. Now that you bring this up, so for the fraction button, I have -4 over radical 14 times radical 5. And there you go. Close that parenthesis. Now you see 2.06. That's in radians. That is a correct answer if you want to put it that way. 3 sig figs. That's in radians. I prefer degrees because I don't really know what 2 radians is. Well, I have some idea, but it's not as easy as it is with degrees, where it's automatic. So I'll put in degrees so you can see what. So that is the angle between vectors. Next, there's some properties of scalar products or dot products that we can use. Basically, it doesn't matter which. So right here we have the commutative property. It doesn't matter which order you multiply them. You do the dot product, it works. If you take the dot product of itself, you happen to get the magnitude of the thing squared. And then there's associated property and like a distribution property. We don't use them as much, but that's the idea. Here's some geometric properties. I'll highlight the one that's super important, and that is this one right here. 2 keywords here for mathematics, for IB mathematics: perpendicular or orthogonal. They mean the exact same thing. So perpendicular or orthogonal, they might even say a right angle. They might even say 90 degrees. All these mean the same thing in vectors. If you have a perpendicular angle or orthogonal angle, right angle, whatever, the dot product equals 0. And I cannot stress enough, this is super important. So they'll say something like, hey, show these two things are orthogonal, or show that these make a right angle. All you gotta do is take a dot product and show that equals 0. Then there's some other rules here. You can separate them. Again, the most important one is that right there. So let's do an example. Find t such that this vector and that vector are perpendicular. So when you see that, you just go, okay, that means the dot product should equal 0. Again, it's only for perpendicular or right angle, whatever, however you want to think about it. And all we do is let's do the dot product, right? So I'm gonna do a dot b. That means you multiply the corresponding parts. -1 times 2 plus multiply the bottom parts 5 times t. And since it's perpendicular, it should equal 0. Now it's just an easy math problem. 5t equals 2, t equals 2 over 5. There you go. Let's look at this next one here. It's a favorite of IB. So they give you 3 points. They say it's a triangle, and they want you to show that it's right angle. So IB likes to make you draw triangles. So I'm just gonna draw a triangle. That's any way you want. Here's A, here's B, and here is C. Again, does not matter. It's any type of triangle. And what we want to do here is find, so if it's a right angle, I should know the dot product of something should be equal to 0. So all we have to do is find these vectors here. So I'm going to find the vector AB from A to B, and we're going to find vector AC. And we're going to take the dot product and hopefully equals 0. If it doesn't, we have to move on. We have to do BA and BC, and then if not, we'll do the final two. So another way to find vector AB, that's going to be tip minus tail. B minus A. B is 6, -1, and A is 2, 1. So I get the vector 4, -2. So that's what this vector is. 4, -2. AC down here, same idea. It's going to be tip minus tail, C minus A. So that's going to be 5, -3, minus 2, 1. And we get 3, -4. So those are my two vectors. So I have the vector here, which is 4, -2, and I have the vector here, which is 3, -4. I want to make sure this is right angle or not, so I just do dot product. I'm going to do AB dot AC. So we're going to dot 4, -2 times 3, -4. And remember, all we do is multiply corresponding parts. So I get 12 plus multiply on the bottom, 8, and I get 20. So that's not the right angle. So now I've got to find another one. Let's do the C first. So I'm gonna do CA. Now CA is I do gotta find that vector, because remember when you do an angle, it's from the angle out. So I do gotta find CA, which is just the negative version of AC. So that's gonna be negative 3, 4, right? If you ever just switch the letters, you negate it. Then we gotta find the one right here. We gotta find CB, tip minus tail. So that would be 6, negative 1 minus 5, negative 3, and that would get me 1 and 2, 1, 2. Negative 1 minus negative 3 is a 2. So that's my CB. So we're gonna do that. We'll find this angle. Dot this vector with that vector. So I'm gonna dot CA with CB. That's negative 3, 4 times 1, 2. Again, it's multiply corresponding parts. I get negative 3 times 1 plus 2 times 4, and I've struck out again. This time I get 5. So this last one better be it. So we're going to go from BA, and again, if you remember what I said last time, so you're going from B to A. So it's kind of like this. And we're going to go this way, the opposite way. We're going to go from B to C. Again, those vectors should be easy. So I'm going to do BA dot BC. All to do with BA is to switch AB. So it's going to be negative 4 and 2. And to do BC, I'm going to switch CB. So it'll be negative 1, negative 2. I'm going to negate it, I should say. If I multiply this, I get 4 plus negative 4. And huzzah, I found the right angle. I found the perpendicular one. So angle B is right. Just my luck. It's the last one. But that's the idea. So they don't actually, IB doesn't specifically ask this question a lot, but it does ask you to draw triangles and find an angle with the triangle you draw. So we'll do a little bit more of that later too. Find the form of all vectors which are perpendicular to 3, 4. Are all the vectors parallel? So you want me to find something that's perpendicular to 3, 4. The easiest way to do this, to find something perpendicular to, since you're multiplying it, is just flip it upside down. So my perpendicular vector is going to be 4 and then 3, but I got to make one of them negative so they cancel out. So it's something like this. So that works, and any multiple of this is going to work. If I did 3, 4 dot negative 2, 4, negative 3. This would be negative 8 and 6 times 3, 4. And look at, you get the same thing, negative 24 plus 24. So any multiple of this flip version will work. So you get something like this. Something like that. All these values are perpendicular to that. Are all these values parallel? Yeah, because the definition of parallel is just multiply any number by your vector and then parallel. So that's the idea. It's more of a conceptual one. Now let's do this last one here. This one's a little involved. So use vector methods to determine the measure of ABC. So angle ABC. So we're talking about from A to this B over here, and then all the way to C. So they want this angle right there. Now a couple things. We're in a 3-dimensional figure. Let me erase this to talk about it. We're in a 3-dimensional figure, so I want it in vector form. So we gotta use our 3D skills that we learned before. This point right here will be 0, 0, 0. Because you always want to start like in the base, like that's the origin. If you go down here, this will be your X. This will be your Y. And going up is your Z. So let's talk about what all these points should be. You went this way in your X. So you only move on your X. Now how much do you move in your X? 4 is like over here. 4 is the Y value. 3 is the Z value. It's going up. What's going horizontal? This 2 there. So this point here is 2 on my X. And nothing else on all the other points. So something like that. I can find all these points, but I'm going to try to find the ones we need, which we are A, and I need B, and I need C. So what's B? Well, how do you get there? You go this way in your Y, which is 4 on my Y. Supposed to do like a little chart here. My Y is 4. So you went this way on your Y, and then you went straight up on your Z. Remember, how much is your Z? It's the up and down ones, the vertical ones, which is 3. I moved nothing on my X. I didn't go over here at all. like the back wall, so that's a 0. So that's the point for B. I need one last point, and that's the point C here. If you can see, C is like the midpoint of this. So I actually did go over on my X, but I didn't go all the way. I only went halfway, which your X, your whole thing is 2, so you went halfway, so that should be 1. How about your Y? Well, it's on the floor. Sorry. You went over here, so you went over 4 on your Y. Right, you're all the way at the edge. So you went over 4 on your Y. My Z is 0 though. You know, it's on the floor, it didn't go up at all. Like this one's up here. I didn't move at all on that one, so my Z is gonna be 0 there. So those are the 3 points I need. Now what we're gonna do is find the angle of this thing. Like I talked about before, the way you find the angle is it's vectors out. So I need this vector and this vector. That'll help me find this angle there. So this top vector is BA. And then this vector right here is BC. So remember, it's vectors out. Right? So if you're trying to find the angle, it should look like this. So let's find BA. It's just tip minus tail. A minus B. A is 2, 0, 0 minus B, which is 0, 4, 3. So I get 2, negative 4, negative 3. That's my vector BA. My vector BC, same idea. Tip minus tail. C minus B. C is 1, 4, 0 minus B, which is 0, 4, 3. And I get 1, 0, 3. I mean, negative 3. 0 minus 3 is negative 3. So that is my BC. Now remember, what's the question? We got to find the angle. So we're looking for the angle right there. So I have my vectors. Now I got to find the angle between it. So we use the formula from the formula sheet. Cosine theta equals A dot B over magnitude of A, magnitude of B. So we just got to fill that thing out and we're done. So let's do the dot product first. So we're in dot BA dot BC. Remember, all that is multiply the corresponding parts. So 2 times 1, negative 4 times 0, and add them up. Also in your formula sheets. And if I do that, I get 2 plus 0 plus negative 9. Positive 9, double negative, so I should get 11. Ooh, almost made a mistake. Okay, so that's the dot product. Now let's find the magnitude. Now when I do this, it doesn't matter which one's A and which one's B. It doesn't matter. Let's just say this is A. So magnitude is the Pythagorean theorem. So the first term squared plus the second term squared plus the third term squared. I get 4 plus 16 plus 9. So I get radical 29. Do the same thing here for B. I'm going to get square root of 1 squared plus 0 squared plus negative 3 squared. And I get 1 plus 9, or rad 10. I'll make it a little nicer so you can see it a little better. It's going to be 11 over 290. 10 times 29, keeping the radical. So we get that. So all we got to do now is put this on a calculator and get our answer. So here's my calculator. So again, we're going to get rid of the cosine. So cosine inverse, so second cosine. I'm going to make it easy to put a fraction, alpha y equals. And I'm just going to go 11 over square root of 290. Over square root, I don't even know what happened there. Over square root of 290. And there we go. 49.7 degrees. So remember, I have 7 degrees, so that's fine. You can also have 100 radians if you want. But that's the idea, and we're done.